This video is on exponent rules as they apply to multiplication. A monomial is a number, a variable, or the product of a number and variables with whole number exponents. A monomial does not contain addition or subtraction, nor does it have any variables in the denominator or negative or rational exponents. Let's take a look at a couple expressions that are monomials and those that aren't. So the following are examples of monomials: 3x squared, negative 4a to the third b squared, and 5/6 t. The following are not monomials: 3m minus 4n, because that's actually two monomials being subtracted. 7 over a squared, that's not a monomial because you cannot have a variable in the denominator. X to the negative 6th power, you can't have a negative exponent. And x to the 3/4 power, you can't have a rational or a fractional exponent. An expression in the form of x raised to the power of n is called a power and represents the result of multiplying x by itself n times. X is called the base and n is called the exponent. Here's an example. So 3 to the 4th power, 3 is the base, 4 is the exponent. That 4 refers to the fact that 3 is multiplied by itself 4 times to give you 81. Let's take a look at a couple properties that apply to multiplying exponents. The first is the product of powers. To multiply two powers with the same base, we want to add their exponents. So the rule says a to the power of m times a to the power of n is equal to a raised to the power of m plus n. Here's an example. X to the third times x to the fourth is x raised to the power of 3 plus 4, or x to the 7th. Why is this true? Well, x to the third is x times x times x. X to the fourth is x times x times x times x, which gives you 7 x's multiplied together, which is x to the 7th. Here's an example. We need to simplify 2a squared b to the third c to the 5th times negative 8a b to the 4th c to the 3rd, or c cubed. To do that, I'm going to multiply my coefficients, the numbers that are out front, and that gives me a negative 16. And then I'm going to look at my a's. I have a squared times a to the 1. That's going to give me a to the 3rd power. Add those exponents. B to the 3rd times b to the 4th. Add the 3 and the 4. That's going to give me b to the 7th. And c to the 5th times c to the 3rd gives me c to the 8th. So multiply the coefficients and add the exponents of the similar bases. Our next property is called the power of a power. To raise a power to a power, we want to multiply their exponents. The rule says a raised to the power of m, the whole expression raised to the power of n, is a to the m times n. Here's an example. X to the 5th, the whole thing raised to the 3rd power, is x to the 5 times 3, or x to the 15th. Why is that true? Because x to the 5th cubed, or raised to the 3rd power, is x to the 5th times itself 3 times. X to the 5th times x to the 5th times x to the 5th. This goes back to our product of powers property, where we add the exponents, which is the same as x to the 15th. Let's take a look at this example right here. Here we have 2 to the 3rd power raised to the 4th power, and that whole thing squared. To simplify this, we're just going to multiply the exponents. 2 to the 3 times 4 times 2 is going to give us 2 to the 24th. And it's actually okay to leave it just like that. Our next property is the power of a product. So to find the power of a product, we want to find the power of each factor and then multiply. The rule says the product a times b raised to the power of m is the same as a raised to the power of m and b raised to the power of m. So for example, I have a product here in the parentheses, 2 times x times y squared, and the whole thing cubed. So I'm going to raise to the 3rd power each of those factors inside the parentheses. So 2 to the 3rd power, x to the 3rd power, and y squared to the 3rd power. 2 to the 3rd power is 8. X to the 3rd, x cubed, and y squared to the 3rd power is y to the 6th. Why does that work? Well, remember what's in the parentheses here, this 2xy squared, is being multiplied by itself 3 times. So it's 2xy squared times 2xy squared times 2xy squared. multiply the coefficients, multiply the x's, multiply the powers of y, and that gives you 8 x to the third power y to the sixth. Let's try this example here. I need to simplify negative 3x squared y z to the third power, the whole thing squared, times 2x y to the fourth z to the fifth, the whole thing cubed, or raised to the third power. So I'm going to simplify each of these separately. So this squared applies to each term inside there. So negative 3 squared is 9. X squared squared, multiply those exponents, is x to the fourth. Y squared is just y squared. Z to the third squared is z to the sixth. Now let's do the second one. 2 to the third power is 8. X to the third power is x to the third power. Y to the fourth to the third power is y to the 12th. Multiply the exponents. And z to the fifth to the third power is z to the 15th. Now I have two powers that I just need to multiply. So 9 times 8 is 72. X to the fourth times x to the third. Add their exponents. That's x to the seventh. Y squared times y to the 12th. Add their exponents. That's y to the 14th. And z to the 6th times z to the 15th is z to the 21st power. So here I have three problems that I would like for you to practice. So please stop the video and copy these into your math journal and do these. Okay, let's take a look at how we're going to solve these. It says simplify each expression. So I have 4a to the third b c squared times negative 5a to the seventh b to the 12th c. So I'm going to multiply my coefficients. 4 times negative 5 is negative 20. A to the third times a to the seventh. Add the exponents, that's a to the 10th. B times b to the 12th, that's really b to the 1 times b to the 12 is b to the 13th power. And c squared times c to the 1 is c to the third power. Number 2 says g to the fifth squared. In this case, I'm just going to multiply my exponents. This is a power of a power, so g to the 5 times 2, or g to the 10th power. And my last example here is negative 2x to the fourth, the whole thing cubed, 4xy to the fifth squared. So this exponent here will apply to each of the terms inside the parentheses. So negative 2 to the third power is negative 8, because negative 2 times negative 2 times negative 2 is a negative 8. X to the fourth to the third power is x to the 12th. Power of a power, multiply. Now let's simplify the second one here. 4 squared is 16. X squared is x squared. Y to the fifth squared is y to the 10th. Now let's multiply our coefficients. Negative 8 times 16 is negative 128. X to the 12th times x squared. Add your exponents as x to the 14th and y to the 10th. So in this video, we took a look at the rules that apply to multiplying powers, that is, expressions that have exponents.